Now, let's talk a little bit more about AI. In your book, you say a statement that is pretty mind-blowing and very scary at the same time. You say that AI is as or more disruptive than was the Industrial Revolution. When we know what happened after the Industrial Revolution, that is quite scary for a lot of people. So could you help us grasp just how much of a shift this is going to be for us?
I talk a lot in this book about a sociologist, actually a Marxist sociologist by the name of Daniel Bell, and he was very influential in the United States in the 70s, and he was a sociologist at Harvard. And in 1973, he wrote a book called The Coming Post-Industrial Society. And this book had a big impact on my life. So in 1973, the world is fully industrialized. We have a production line. BMW and Daimler and Ford are making automobiles. We're building highways. People are just starting to buy TVs. Everybody's happy. Okay? And this is before the internet, before the personal computer, before the fax machine, before any of these things. This sociologist, Daniel Bell, predicts that the planet is about to incur a restructuring of the global economy on the order of the Industrial Revolution, and he calls it the Information Age. And he calls it the Post-Industrial Society, which is where we are now. And he says, and he kind of talks about the evolution from, pre-agrarian societies, hunter-gatherers, to agrarian societies, to the Industrial Revolution, and now the post-industrial society. And all these were technology-driven. The invention of agriculture, say 12,000 years ago, domestication of agriculture. This was a big deal. Okay, the invention of the steam engine, the Jacquard loom, okay, in the 18th century. These were big inventions. How about the printing press? Okay, what is printing press? I think 15th century, and the printing press drove the Reformation, right? So all of a sudden we can print Bibles in language other than Latin, in English, in French, in German, okay, in Swedish. And what happens? We have hundreds of years of religious wars in Europe as a result. So, I mean, this was the concept. So I think the printing press was generally a good thing. I think we'll all agree to that. But the negative consequences of the printing press were pretty deleterious. Let's take the steam engine and the Jacquard loom. Well, these drove the Industrial Revolution. And I would argue that the Industrial Revolution was generally a good thing. People live longer. People are healthier. There are more jobs. We have higher standard of living than we had before the Industrial Revolution. And yet, sociologically and in a historical context, we can draw a straight line, okay, between the invention of the steam engine, okay, and child labor, okay, communism, World War I, World War II. I mean, I would argue these are pretty deleterious consequences. Now, as it relates to AI, I think AI changes everything about the information technology world. It changes everything about the way we communicate, everything about the way we recreate, everything about the way the business of leisure, the business of living, and the business of business. And we will produce products at lower cost. We will deliver them into the hands of more satisfied customers. We will have a more healthy population. We will lower the environmental impact dramatically of power production, generation, hydrocarbons, what have you. So a lot of the consequences are enormously beneficial. At the same time, this is just like every other big technological change. There are going to be negative consequences associated with these changes. Let's take precision health. I believe precision health will be the largest application of AI. So we can today, we have the capability today to take the population, say, of France or the population of the United States and take the healthcare records and the genome sequences and the health history of those populations and aggregate those data into a unified federated image. And then we can apply machine learning to those data to enormous economic and social benefit. For example, we can predict in France, in the UK, or in the United States today with very high levels of precision who is going to be diagnosed with what disease in the next 5 years? Well, if we know this, we can intervene clinically now and avoid the diagnosis, say diabetes or whatever it might be. How about genome-specific medical protocols, which will be highly efficacious, okay, and lower the cost of healthcare and dramatically increase the efficacy? Or AI-assisted medicine. I don't think that AI is going to replace the physician anytime soon, but it will most certainly assist the physician with more accurate diagnoses. Now, all of this is goodness and light, right? I mean, what's the downside? We live longer, healthcare is cheaper, people are healthier, it's all good. What's the problem? Well, the problem is either the healthcare provider, or it's a private healthcare provider in the United States, or perhaps the government, okay, in Europe, okay. I mean, think what they know about us, okay? They know which of us is going to be diagnosed with what disease in the next 5 years. And how are they going to use those data? I mean, do you want to know that you're going to be diagnosed with a terminal illness in 2 years? I'm not sure I do. Are they going to use it to set rates? Are they going to use it to withhold health care? Okay, who needs to worry about? In the United States, we talk a lot about pre-existing conditions. Who cares about pre-existing conditions when we know what you're going to be diagnosed with in the next 3 years? So I think the privacy implications and the ethical implications associated with this technology are very troubling. And I think that unless we anticipate these negative consequences, okay, and take action to prevent the negative consequences, particularly associated with privacy and the misuse of these data, and we know that both governments and private enterprise, okay, do not behave well when they have power like this. Okay, see Facebook for details. So if we don't anticipate the consequences, we will have to live with them. So I think there are some very, very important. It's not all goodness and light. It will happen. It is unstoppable. Okay, it is like agriculture. It is like the printing press, and it is like the Industrial Revolution. As much as we might want to tax it or regulate it out of existence, it is unstoppable. Okay, but we do have an opportunity to consider what the negative consequences will be, and to avoid these consequences, and hopefully we'll be smart enough to do so.
Now, you often talk about the trade war that's happening between the U.S. and China, and you say it's not a war that we want to lose. What's at stake here, and who do you think has the most chances to win this war right now?
I think this is a very important subject, and if you haven't read this book, AI Superpowers by Kai-Fu Lee, I strongly recommend it. Kai-Fu Lee is an ex-Microsoft executive. He used to run Microsoft China. He used to run Google China, and he is a very bright guy. And it's a pretty scary book that talks about what's going on with AI in China. Vladimir Putin said in 2017 that whoever wins the war on AI dominates the world. I believe that's true, and it's not going to be Russia. Okay, I think today we are engaged in kind of all-out war in the area of development of AI between China and the Western world, this being the Western world and the United States. And this is a fundamental test of two diametrically opposed political philosophies, where in China we have a top-down command and control totalitarian state where everything is dictated by the 12th, 13th, or 14th five-year plan. And today they're investing $20 billion a year, soon going to $60 billion a year, to have 1 billion people operating in lockstep for the development of these technologies. Now, in the Western world, things are not so well organized. Particularly in the United States, the free enterprise system is a pretty messy function where innovation happens in garages in Palo Alto and storefronts in the Bronx. And I'm not certain, I think this is going to be the ultimate test of two fundamentally opposed political philosophies. The command and control totalitarian state against basically, free enterprise democratic states. And this is a war that we do not want to lose because this should be a problem. I think in some ways this war is asymmetrical because in the Western world, we have, I know in Europe, and I spend a lot of time in the Pentagon, so I can tell you these people think about it a lot. They have very, very clear ethical guidelines about how they can use AI and what they won't use AI for. For example, in the Pentagon, there's a human in the loop in every decision. Well, I think when we get to China, I'm not certain they're going to be constrained by these types of ethical constraints. So it's an asymmetrical problem, and it's very troubling. But I'm confident. I mean, we are at war. The financial systems, the energy systems in the United States and Europe are being penetrated every day by the Chinese, where viruses are being planted there so that they can turn off the financial network or turn off the power grid whenever they might like to. In the United States, the Office of Personnel Management in the United States was penetrated by the Chinese. They stole 21 million personnel records, including the records of every person who has ever applied for or been granted a security clearance. I mean, if this is not warfare, what is it?
How would you describe the behavior of big tech in the U.S. when it comes to that war? Let's say Google, Facebook.
Okay, so I'm going to get myself in trouble here, as I invariably do. And I mean, the people who run Google are good friends of mine. Eric Schmidt is a good friend, and Larry and Sergey are friends. And yet, this idea that a U.S. technology company is unwilling to support the United States government in defending freedom around the world is simply unconscionable. I mean, these people at Google, they're basically leveraging Department of Defense investments, to build their houses and to build their mansions in Silicon Valley. I mean, they didn't invent the internet. The United States government did. As you know it today. They didn't develop the GPS system. The Department of Defense put the GPS system, in place. So these companies are just standing on the shoulders of DoD investments, and they're unwilling to help the United States in helping defend the free world, and yet they're happy to collaborate with China, of all places. Then next week, they announced that they're collaborating with China, to set the standards for personal privacy on the internet. Is this a joke? And so I think it's a little bit troubling, and it's not the greatest day for Silicon Valley.
Do you agree with Kai-Fu Lee that we're coming to we're going to see the end of Silicon Valley, at least as we know it?
Well, I think that, this is not the first time that there has been a collision between the East and the West in history. These collisions go back millennia. And some of you will recall there were some pretty effective leaders by the little bit like Genghis Khan who did a pretty good job of covering a big chunk out of Europe. And if I'm not mistaken, the Nation of Islam, did a pretty good job starting about 700 AD to occupy, much of Christendom and a big chunk of Europe. So this is not the first collision between the East and West. I don't think it'll be the last. But somehow, Western civilization seems to always come out on top. So let's just keep our fingers crossed.
Very well. Let's talk about C3 AI. You're helping many different companies now in lots of different sectors take that digital turn. So give us examples of how you're helping your customers. I know, for instance, that you're working a lot with Engie.
Well, again, this is my fourth decade in the information technology industry, and I can tell you no one has had more fun than me. And I was involved in bringing relational database technology to market. I was at the table when we brought enterprise application software to market. And now I have an opportunity to have a place at the table as we bring artificial intelligence to market for commercial and industrial use. And, I get to work every day with visionary CEOs who are changing their industries. So Isabel Kosher is most certainly a visionary CEO, and she is driving massive change at NG through this project that she calls NG IoT, which is really about AI, and we can talk about this. And I see IoT and AI is really two sides of the same coin, but there is no corner of their business, okay, that is not being changed with M2M, B2B, B2C, gas distribution, electricity distribution, massive work that we're doing in smart cities, and this is being driven by a visionary chief digital officer by the name of Yves Legillard. At Royal Dutch Shell, which is the 5th largest company in the world, we're involved in massive change in digital oil fields, and this is using AI to increase lower the cost and increase the safety of exploration, production, and distribution of hydrocarbons, and to dramatically increase the use of renewable energy in these renewable energy systems so that we can deliver energy that is more clean, more safe, and much, much more environmentally friendly. And so that initiative they call Shell.ai, and it is a very large-scale initiative. We're also working with a CEO by the name of Lorenzo Simonelli at a company called Baker Hughes, which is a large oil and gas services company. So with them, we're doing the same thing that we do at Royal Dutch Shell with Think, Saudi Aramco, SABIC, ADNOC in Abu Dhabi, Chevron, what have you. So these are massive scale energy initiatives. Also in the area of clean energy, we do a lot of work in the electronic utility business. This is the value chain of power generation, transmission, distribution, and consumption. And we can use AI and IoT to increase the efficiency of the grid. The grid is the largest and most complex machine ever built. And we use these technologies to increase the efficiency, increase the reliability, increase the resistance to cyber attack, and reduce the greenhouse gas effect of power generation, transmission, and distribution by a factor of 2. So we do this writ large at NG in France, at Enel in Rome. Enel, we have this is being driven by their CEO, Francisco Starace, and he's looking for 6.7 billion euros in recurring economic benefit from these initiatives. We also do this in the United States at Exelon, New York Power Authority, Con Ed, Duke, and many others. Other examples. In manufacturing, we're able to use AI to engage in a process that we call stochastic optimization of the supply chain, which optimizes the number of parts in the supply chain and deals with the whole problem of supply network risk. And these supply chains at companies like 3M and Caterpillar, General Motors are just massive. Okay, and the idea that when we can optimize these supply chains, we can dramatically reduce the cost of production, reduce the cost of the product, and deliver a better product into the hands of a more satisfied consumer. There's one of the kind of the killer application in AI today is AI-based predictive maintenance, where we can look at large machines like the AWACS for the United States Air Force, the F-15, F-16, F-18, F-35 Joint Strike Fighter, and look at all the telemetry that are coming off these machines, and it's a lot of telemetry, okay? And then we can look at some of these devices on any given day, only 50% of them will deploy. Pilot goes into the device at, say, F-15, F-16 to ODark 30, pushes the button, some red light comes up and says you're not flying because the system is broken. So we can use AI-based predictive maintenance to identify system failure before 50 or 100 flight hours before it happens, and then they replace the device before it breaks, and it increases the availability of aircraft from say 50% to 80%. AI-based predictive maintenance for offshore oil rigs. I mean, it reduces the probability of an environmental catastrophe by orders of magnitude, and we can predict failures in devices like, downhole rigs, low-pressure compressors on offshore oil rigs, oil factors by. I mean, we can identify a failure, many days in advance, so we can avoid catastrophe and continue production. So these are the types of projects we're involved in at United States Air Force, Royal Dutch Shell, Caterpillar, 3M, Enel, Engie, and others. And these are massive scale projects. Give you a feel for one project that we're involved in at Royal Dutch Shell. Royal Dutch Shell has 500,000 valves in its system. This has to do with upstream, downstream, refining, the works, 500,000 valves. And one of these valves gets stuck open or shut, things go real bad real fast. And so we're managing, both in terms of descriptive analytics, the state of each of one of these 500,000 valves in real time, and then with predictive analytics, we're building machine learning models to identify valve failure before it happens. And this contributes to lowering the cost of production and increasing the safety of production. And so in order to do this, we've loaded 267 billion rows of data. Okay, these data arrive at 100,000 rows a minute from 50 different sources. Okay, we process these data at the rate of, say, 1 million transactions per second, and in synchrony, we're managing 2 million machine learning models, okay, to achieve this task. This is the second largest AI IoT application deployed on Earth. The largest is Enel in Rome. So Enel in Italy and Paris, we've aggregated the data from 42 million smart meters, 75 million sensors. This is 10 trillion rows of data into a unified federated image. We go out to the extranet. This is all of their enterprise information systems. You've thought about this, okay? SAP, customer care and billing, SIEBEL, Salesforce, Maximo from IBM for inventory, Atlas for network topology, 2 different SCADA systems, one from Siemens, one from Schneider, their work order management system. Then we go out to the extranet for terrain, social media, and weather. So this is 10 trillion data, 10 trillion rows of data, aggregated into a unified federated image. We process these data at 1 million transactions per second, in this case in the AWS cloud, for 5 sources of economic benefit associated with AI-based predictive maintenance, identifying who's stealing energy, how much are they stealing, and how are they doing it. You get to places like Sicily, these are pretty big numbers, and then customer churn. So the economic benefit of that application today is 291 million euros in recurring economic benefit. That is the largest AI IoT application deployed on Earth. So these are the types of things we're doing. They are really hard, really exciting, really challenging, and really, really rewarding.
We're starting to run out of time, but before we take a couple of questions from the audience, I have one last question. Many people have described you as someone who has stared death in the eye, and I'm referring to what happened in 2009. You were on a safari in Tanzania, and you were stumbled upon literally by an elephant. You had 19 surgeries. You weren't able to walk for 4 years. The question I have is, how does such an event change someone's life and a man's perspective on life? What did it change?
I've had a few opportunities to stare death in the eye. For many years, I had to stare Hasso Plattner in the eye. And for some decades, I stared Larry Ellison in the eye. And then I managed to survive those near-death experiences pretty well. In both exceptionally talented people, by the way. But they're formidable competitors. In 2009, I was on safari with my daughters and wife in Tanzania, and one day they stayed home, and I went on a walking safari, and I was attacked and mauled by an elephant. And this elephant was, say, 5 tons, came from 200 meters away. And these elephants move at about 30 miles an hour. So 5 tons at 30 miles an hour, and it hit me, mauled me, beat me up. I took a tusk through the leg, stepped on my left leg, stepped on my right leg, and my foot came off. So it was a bad day. And in the following 3 years, I had 19 reconstructive surgeries. I spent much of that in an electric wheelchair as if a quadriplegic. And then 4 years later, I walked. And today, if you visit my office, you'll see right next to my desk, there's a very large photograph of a charging elephant about 4 feet away. And I'm here, and he's not.
You won. Tom Siebel, thank you very much for that. We're going to take a couple of questions from the audience. Just
Please.
don't be shy. Any questions?
Might get off easy
All right,
today
well.
in Paris.
The first one is always complicated.
So maybe we're going to give a couple minutes to people to think about a question. I actually have another question.
Okay.
What are the KPIs of a good digital transformation? Are there any indicators that can tell you that you're on the right path in your digital transformation?
There's only one KPI that matters, and that's economic benefit. Okay, hard stop. Okay, so the companies that succeed are not boiling the ocean. Okay, forget about using AI to start by digitally transforming all of Sanofi, or digitally transforming all of Renault, or digitally transforming all in one big bite, all of oh, come on, who's the aircraft manufacturer here? The big one. Huh? Competes with Boeing. Airbus. I mean, it's not going to happen. Okay, it's going to fail. It's too complex. It's too big a problem. Take a tractable problem. Okay, keep it simple. What's a tractable problem? Stochastic optimization of supply chain for one factory. AI-based predictive maintenance for one product. Okay, customer churn for one division of your bank. Take high net worth division for France, or cash management. Okay, anti-money laundering for one country. Okay, this is a financial services application. Anti-money laundering, cash management. Keep it simple. Take a project. Okay, determine what is the economic benefit of that to your company, and do the project. Make the project. Forget about these. Accenture-driven, 300 people for 5-year, 500 million euro projects. Okay, forget it. You have 5 million. 5 years later, you'll spend 300 million euros, and you'll have a big data lake and nothing to show for it. Pick a tractable project, put an economic benefit on it, and achieve the economic benefit. Okay, that is the only KPI that matters. Okay, how many millions of euros a year are you saving for your company? Okay, then once you do it once across one product line, or one division of the bank, or one model at Airbus, then scale it across the enterprise and turn tens or hundreds of millions of economic benefit into billions of euros in annual economic benefit. Keep it simple, do it fast, get it done, and get your CEO on board. Because if your CEO is not on board, I'm telling you, it's not going to happen.
Now, a lot of people in this audience are from big firms here in France. A lot of big firms are struggling today to retain talent, young talent, who would rather go and work for startups or work for C3 AI. I don't know, one or the other. But What should they do to be able to retain that talent?
I think the most important thing is continuing education. I mean, number one, in order to pull this off, you're going to have to retrain your workforce, you're going to have to retrain your CEO, and you're going to have to retrain yourselves. Now, as we work into this 21st century economy, and there are enormous resources that are available to us to train our people. You're going to either have to retrain your people or you're going to replace your people. Come on, which do you want to do? I mean, nobody wants to replace people. And so if we're at C3, for example, now we're much smaller than you, granted, okay? But, and our workforce is arguably technologically more articulate than yours. They all have, master's degrees in data science from Ecole Polytechnique or MIT. Okay, that being said, as bright as our workforce is, we assume that they're obsolete the day they show up to work. This is a very rapidly moving field. So at C3, for example, we've adopted a curricula. We've curated a curriculum from Coursera on, artificial intelligence, elastic cloud computing, machine learning, unsupervised learning, deep learning. And we motivate our people to take these courses. They do it on their own time. And when we get their certificate, we give them, $1,000 or $2,000 for completing the course. We give them recognition in the company newsletter. And we have a big wall of fame in our headquarters building where we recognize them for their achievement. So we have a culture of self-learning. At C3, for example, if someone, I think about 70% of our people have advanced degrees, but for people who want to seek an advanced degree, say in computer science or in data science, they have an online program at many universities in the United States. We happen to use the University of Illinois at Urbana because that's my alma mater, and where if somebody wants to go get their degree in computer science, online, okay, we pay the tuition, we pay the fees, and when they get their degree, we give them a bonus for $25,000, additional equity in the company, and a 15% increase in satisfaction. Excuse me, a 15% increase in compensation. It's an enormously popular program. So very much part of our culture is about self-learning. This is what we recognize. And, the receptionist, for goodness sake, has taken a course in machine learning. She's taken a course in AI. I mean, how exciting is that? And so you have people who are, they feel like they're empowered to do their jobs. Okay, their resumes are stronger. They're able to feel more rewarded about what they do to serve customers better. And I believe that in the future, all of us will be doing this. But the resources that are available today to train our people through continuing education is hugely important. Now, the other thing we need to think is about, and I know you think about it, and I think about this more than anything else, is the workforce has changed. Okay, and it's changed dramatically. It used to be simple, say, 50 years ago, when we were just dealing with baby boomers, right? Baby boomers are easy to motivate, okay? We all learned about Maslow's hierarchy of needs, okay, that, as the motivation, as human need was what motivates people in our college classes. Well, it's a bunch of bunk as it relates to baby boomers. Okay, baby boomers are motivated by the compensation plan. And whatever you write down in the compensation plan, they do. Well, life's not so simple anymore. I mean, we have this workforce that we work with today is a very rich tapestry, of baby boomers and millennials and Gen X's and post-millennials, and they all have a different sense of history. They all have a different sense of different motivations, different reasons to work, different senses of work-life balance. And so the key to this is culture, okay? And culture just, kind of eats up corporate policy, right? And, culture is everything. So I think that, really understanding that rich tapestry and trying to find a value system that will motivate this highly diverse, highly talented, yet highly complex workforce, to work together as a team to accomplish something of benefit to the company, the shareholder, the customers, and their families. This is the task of management, and this is why all of you guys make the big bucks. And so I think we need to think about that, and that's what it takes to attract, motivate, and retain the best and brightest that'll take you into the 21st century.